So let's say you have y double prime plus y equal to x times sine of x plus e to the x cosine of x. And if you try to solve this to the end to find the general solution, it's going to take a long, long time. So instead of asking you to solve it, sometimes I might put a question like this and say, find the appropriate form of yp for method of UC, undetermined coefficients. In that case, what do you do? Oh, solution. First, you need to start with a complementary solution. How do you do the complementary solution? Complementary means the solution of the homogeneous differential equation. And the characteristic equation is r squared plus 1 equal to 0, whose solution is r equals to plus minus I. And remember, if r is a plus minus bi, in that case, your solution should be e to the ax, a c1 cosine bx plus c2 sine bx, right? That's the general solution if your characteristic equation becomes a complex number. And for our case, what's a? 0. What's b? 1. So for our case, what's our solution? Yc is e to 0x, which is just 1, and e to the 0th power is 1. c1 times cosine x plus c2 times sine x. Okay? So that's the complementary. Why do we need the complementary to find the particular? Because we have to check for duplication. Duplication is this horrible issue when you use the method of undetermined coefficients, right? Yes?
Would you want us to keep the e to the 0x, or could we just...
Oh, no, of course, you should delete it now. So that's the complementary, okay? All right, so that's the complementary. Now let's look for yp. All right, what do you put for yp? Well, you first list all these functions, right, that you see on the right. But you have to also include all the functions produced by their derivatives, right? All the terms in the functions that are in the derivatives and the second and so on, right? If you differentiate this once, what do you get? You get just the sine x, and then if you differentiate sine, you get cosine. So I think you get sine x from here. The first derivative is sine x plus x cosine x, right? And if you differentiate sine, you get cosine. If you differentiate x cosine x, that's cosine x minus x sine x, right? Okay. So this is what I see. I have x sine x, x cosine x, sine x, and cosine x. And you'll never see anything else. If you continue to differentiate like third time, fourth time, fifth time, no matter how many times you differentiate, you'll always only see terms that are looking like this one, this one, this one, this one. This those four. Okay? So I put a x sine x, b sine x, plus c x cosine x, and d cosine x. And one thing that you should also take notice is that they should be forming a single group. This should be thought as a single group. This is not good. They form a single group. This entire thing is a single group. Okay? Now, what about e to the x cosine x? If you differentiate e to the x cosine x, what other terms do you see? Would you get? What do you get if you differentiate e to the x cosine x?
EX sin x.
You get this, right? Yeah, that's the new one when you differentiate. So what should you include? E times e to the x cosine x plus f times e to the x sine x. That's it, right? There's no other terms. If you keep differentiating this, if you did it correctly, you'll only see these terms appearing. You'll never see anything else. Agreed? Now, it doesn't stop here. By the way, these two form a single group. Now, let me ask another question before I move on to the right answer. What if I had plus e to the x sine x here? Would the answer be different? No, it wouldn't, because this one is included in here, right? So they would belong to the same group. They would both be covered by this single thing. Okay? So whether I have this, or 5 times this, or 6, or whatever, this term wouldn't create anything new in our YP. What if I had instead e to the 2x sine x included? Then you would have another group, because e to the 2x sine x and e to the x cosine x, these are linearly independent. They're different functions. So in that case, I will need a whole different group produced by this extra term. Okay? So you have to know when to add another group or when not to. Right? Okay, so coming back. So this is what I have prepared just by looking at the right side. However, now the second step is to look for duplication. What is duplication? You look for the complementary and see if these appear in your YP. Do they appear in the YP? Yes, right here. No. Right here, cosine x, right? And sine x, right here. Okay? So they appear. So these are duplicated here, meaning that these terms, when you plug in the left side, they're just going to disappear, and making these kind of useless, right? So because these terms are weak, you need to strengthen this group. The entire group has to be strengthened. How do you strengthen a group? Huh? You multiply by x, okay, until you completely avoid duplication. So here's x. If I multiply x to this group, the entire group, now there is no duplication between yc and yp, and that's it. Okay? So that's your answer, because it said find the appropriate form of yp, and this is the appropriate form of yp. Now, if you were to actually solve this differential equation, what do you do afterwards? Plug this huge thing to the left side, compute, and find a, b, c, d, e, f, all of them. And add, after getting all the values of a, b, c, d, e, f, you add yc to it, because the general solution is yc plus yp. That's how you solve it.